Hi, I'm John Ellis, and I'm here for another episode of Optical Engineers at Work. With me again is Sergey, and we're going to talk about a PillCam study that we did a few years ago. There was a previous episode that we'll link to where we looked at the illumination system in the PillCam, and today we're going to look at the optics and possible lens solutions for that PillCam. This was a project where we were sort of studying and doing some reverse engineering on existing PillCams that are on the market, and then determining whether there was a not too complicated path for our client to make a rough prototype to do their own kinds of experimentation. So we appreciate you being here, and please remember to like and subscribe and put questions and comments below. All of those things help us find more people interested in optical engineering. All right, Sergey, let's talk about this project. So, as I said in the past, we looked at the illumination of the PillCam, and here we see it again, where we have a bunch of, I guess these are LEDs on either side of this pill-type device that a customer would swallow if they were going to do a colonoscopy. And then this black thing is a lens. Is that right?
Yes, you're right.
And then we have this plastic cover, and probably behind these lenses is some cameras. So in this report, you were trying to figure out what kind of lens was needed. So tell us about what those requirements were and what was important, and also how did you determine these requirements? How did you know that these were the right requirements?
We disassembled PillCam and measured all of these characteristics in our lab. We measured field of view, f number, working distance. Also, we measured sensor size. We estimated resolution of the lens with help of special tests, and that's all.
Okay, so you took the thing apart and were able to turn on the camera and use the lens and take images, and that's how you came up with this.
Not only images, there were various of different tests, not only images. We make images for resolution estimation, sometimes for field of view definition, but not necessary. We used a lot of different tests for this.
And for resolution, you usually take a picture and then put some kind of test chart in the field of view and see what you can resolve. Is that method that you used? Yeah.
Yes, we put some kind of glass test chart with very teeny stripes on it, and some of these stripes can be seen through the microscope lens only, and this is the way to estimate resolution possibilities for the lens.
Got it. Okay. All right. So after you had those requirements, you started to see what was available off the shelf. So the task here was not that we were going to design a custom lens, because this was more about making something quickly, but to find something off the shelf. So what is your process for looking for off-the-shelf lenses?
This is the searching of the shelf lenses. So first of all, we're trying to find suppliers who works with such technique, with such devices, and then we're trying to see what is available in the market. We look at the requirements for the lens, and we are trying to compare requirements with the achievable characteristics indicated in the data sheets, in the documentation. We communicate with the suppliers very often to clarify some questions regarding the candidates for, in this case, for the lens.
Okay, so you're doing some internet searches, you're finding likely candidates, and then because not everybody publishes the same information or publishes all of the information, you're having to reach out and get details that might have been missing from the data sheet and find the people at the company who know the answers to these questions, I guess. Is that right?
Yes, this is right.
Okay. So now this first lens, and this is part of a much larger report, and I don't think it makes sense to look at all of the work that you did, but this first lens was not a fit. And what was the primary thing you were noticing that was a problem with this lens? Is it you see the field of view is
much smaller than the client need. Yeah.
Okay. The size, it was quite small.
Size looks good. Resolution is great. Sensor size, yeah, this is also issue for this lens, because client planned to use a little bit bigger bigger sensor, and field of view of the lens smaller
that was the main one. Okay.
Yeah, f number also great. This lens will provide higher irradiance of the image plane
That was a benefit. Okay.
than requirements. Yeah,
Collect more light. Yeah. Okay. All right. And then this next one was a bit better. Is that right? Tell us about what you thought of this one.
this lens is closer to requirements. It has wider field of view than previous lens, but not so wide as the client needs. It has great f number. It has very good working distance, range of working distances. But it requires bigger image sensor to provide the indicated field of view. And also on the right side of this slide we can see that this lens provides TV distortion. It means that the image can look like a pillow or like a barrel, especially at the edges, and it also can be potentially important for our client, and this is why this information is indicated here.
And then now we have a third vendor, Q-Optic, and tell us about this lens.
This lens is a little bit better than the previous lens. It has field of view that almost fit the requirements of the client. F number a little bit worse that the client needs. Working distance is okay. Sensor size, it can be an issue, because the field of view that is indicated for the lens from Q-Optic, it works with the bigger sensor. It means that if we will place smaller sensor in image plane, the field of view will be smaller. So this means that the sensor size will limit the field of view of the optical system, not the lens. Lenses can provide wider field of view, but we use too small sensor for it.
I see here you made a note that would reduce the field of view to 110 degrees.
Yeah.
All right, so better, but still not a fit. And here's your conclusion, which is, I guess, that we didn't really find a right lens. If we were going to proceed with making some kind of rough prototype, we were going to have to either accept some trade-offs or do the work of designing a custom lens, which would be a longer process. Also, you're seeing a long lead time here for one of these off-the-shelf lenses, which is not uncommon, but a little strange since it's described as off-the-shelf, but it takes 3 months to get. One thing I didn't notice was there a distortion value on the lens that you tested? Your very beginning with your testing here, did you come up with a distortion value when you were looking at this field of view?
To say the truth, I don't remember. I can say that for such wide field of view, usually we have some kind of distortion.
Just inherently, yeah.
It is impossible to create such a lens and have no distortion. This can be one of two types of distortion, but yeah, it will be.
All right. Well, thank you, Sergey. Again, this video is kind of a companion video to our first episode about the PillCam, where we looked at the illumination. So if you're interested in this subject, please take a look at that. And as always, please like and subscribe our videos. We're interested in your comments, so comment down below. And thanks again for your time, Sergey, and we'll talk to you next time.
Thank you, John. See ya.
Thank you.